Hello, this is Mrs. Lewis with today's lesson on the connection between work and kinetic energy. Let's say we start out with a skateboarder at rest. In order to get the skateboarder to move, we must do work on the skateboarder. Because of inertia, he will tend to stay at rest, and in order to change that, we must do work on him. To do work, we must exert a force over a distance. If we exert a force over a distance, the skateboarder will move. He will accelerate from rest. Once the skateboarder is moving, he has kinetic energy. Kinetic energy is the energy of motion. The skateboarder was at rest. Now he's been accelerated. When he was at rest, the kinetic energy was zero. Once he gets accelerating in motion, the kinetic energy is going to increase. The work done on the skateboarder to set him in motion increased the kinetic energy of the skateboarder. It was zero. Then when we did work, he got more kinetic energy. Now, the amount of work done is exactly equal to the increase in kinetic energy. That's very important. If we want to know how much kinetic energy he has, we can calculate the amount of work done on him, because the amount of work is equal to the gain in kinetic energy. Remember, he started at zero, so whatever kinetic energy he gains is because of the work we did on him. So, since the amount of work that we did on him is equal to the kinetic energy he gets, then it would stand to reason that the units of work and the units of energy are the same, and those units are both joules. Let's say we exerted a 15 Newton force forward and we caused the skateboarder to move 10 meters forward. We can use the work equation, which is force times displacement times the cosine of theta, and the force was 15 newtons, the displacement 10 meters, and since the force was in the direction of the movement, the angle between them was 0, so the cosine of 0 is 1. We did 150 joules of work. And now we know that 150 joules of work is equal to the 150 joules of kinetic energy that we increased in the skateboarder. The work in this case is positive because our force is exerted in the same direction as he's moving. So, since the work is positive, the change in kinetic energy is positive, and that means that when we did this work, we added energy into our system. So that brings us to a very important theorem in physics. It's called the work-energy theorem. And it says that an object's kinetic energy changes by an amount equal to the amount of work done. So when we did work on our skateboarder, the total work, this is a sum, or this is the total work that we did, is equal to the change in his kinetic energy. That would be his final kinetic energy minus his initial, and his initial was 0. So we know that the kinetic energy formula tells us that the kinetic energy of a moving system is equal to 1/2 the mass times the velocity squared. If we combine these two equations, the work-energy theorem and the equation for kinetic energy, we get this fancy theorem right down here. So this says the total work is equal to 1/2 mv squared, the final velocity, minus 1/2 mv squared, the initial velocity. And we know that that was 0. So we can use this and we can calculate the final velocity of our skateboard. All we need to know is his mass. Let's say that was 100 kilograms. So we know that 150 joules of work is going to be equal to the kinetic energy final minus the kinetic energy initial. And so we know that his initial velocity was 0, so therefore 150 joules is equal to 1/2 mv squared of his final velocity. In this case, we're going to take our equation and we're going to solve for velocity. So velocity squared equals the work divided by 1/2 the mass. And so when we solve that, we find that the velocity squared equals 3. When we take the square root of 3, we get the final velocity, which is 1.73 meters per second. So now we can calculate that final velocity just from knowing the amount of work done. Let's look at a little different situation. Suppose we have a skateboarder, and this skateboarder is moving forward with a constant velocity. We know because of inertia that that skateboarder will continue to move forward with that constant velocity, no force operating on her. Suppose, however, we apply a force and we stop her from her movement. So she's moving forward, but we apply a force in this direction to stop her. We would be doing negative work because she was moving this way. Our force goes this way in the opposite direction, so our work would be negative, and that work would cause her to stop. As she slows down, her kinetic energy would decrease, and when she came to a stop, the amount that the kinetic energy decreased would be equal to the work that we had to do to stop her. So now, in certain situations, when the work is positive, the kinetic energy increases. When the work is negative, the kinetic energy decreases. We'll be working on some problems with this in class today.